What's the differential of this multivariable function? To solve this question, you need to know what a differential is. So here's the definition. This is just saying that the differential df describes the change in f when you have a change in x1 and or x2 and or xn, so on and so forth. So you could think about all the different ways you can make changes to any of the variables, and this gives you a precise description using the partial derivatives of the output that is going to be changing from this change in inputs x1 to xn. So this is good. The f is partial f partial x1 of dx1, partial f partial x2 of dx2, and so on and so forth. You will use that now. So dr is going to be partial r. Now we'll take the partial with respect to the first variable, then multiply by d of the first variable. So you do this twice, many times again. And you get, and one more time. Gamma. Very good. Then the goal really is to compute these three terms. And if we are able to compute them, then we're done. Because in principle, these are, I don't want to say constant, but they are fixed in our sense, in that sense. So here they are fixed. We take the partial derivative of r with respect to alpha. We get beta squared cosine of gamma. We take the partial with respect to beta, we get 2 gamma beta cosine of 2 alpha beta cosine of gamma. Sorry, I'm not Greek. Maybe if someone is they can read this, but I'm not Greek. I don't know how to. Sometimes I mix up alphas and gammas. Sometimes I mix them so badly I have to shoot videos once again. But I'm glad that this one is, in this one, this is not the case. So let's go on. The derivative of the cosine function is negative sine of omega. So since we have the three coefficients, then in principle we should be done with the problem. And I say in principle because this might not be the answer, right? Maybe I'm lying to you, or maybe I'm hiding something. Well, not really. I'm just going to remove these and I'm going to put in the coefficients. Do like this. And then this goes here. And then instead of the plus, you have the minus d gamma. Now again, these, I don't want to say differentials because I don't want you to get confused, but these differentials are fixed. And from there we get the final answer. So this is, it's not rocket science, I would say. You need to know the definition beforehand. I think that's probably the challenging part. But since this is an exercise, you can always look it up and see how to do it. And if you know how to take a partial derivative of a function, then you should be more than prepared to solve all exercises of the similar type. This is the end of the third tutorial. Thank you for watching, and I'll see you in the next one.